In this we want to sketch out the basic anatomy of the brain. And when we think about a brain, it's useful to start thinking about a boxing glove. So here we have a boxing glove, something like that. That'll be where your thumb goes. But this is actually very similar to the brain. This is the large upper part of the brain. And the large upper part of the brain is called the cerebrum. So the cerebrum is this large upper part of the brain. Now there's another part of the brain about here, and this is sort of a long, thinner part, and this is the brain stem. And this is towards the front. So this is the front here, this is the back over here. And then also, there's a bit of the brain just behind here, like this, shaped for all the world like a cauliflower. And this bit here is the cerebellum. So the three main parts of the brain, the large cerebrum, the brain stem, and the cerebellum. And the brain stem is continuous with the spinal cord. So this will be the spinal cord here, running down out of the cranial cavity, down through the vertebrae. So the hole in the base of the skull will be just here. The large hole in the base of the skull is the foramen magnum. So the base of the brain stem and the top of the spinal cord is the foramen magnum, the hole where this leaves the brain, where it leaves the cranial cavity. Anything above the foramen magnum is going to be brain, anything below is going to be spinal cord. Now, the brain is going to be divided into lobes. So within the cerebrum, first of all, we have various lobes. Now, the large lobe at the front here is simply called the frontal lobe. This is the frontal lobe. And the frontal lobe lies underneath the frontal bones of the skull. That's one of the good things about the brain and the skull. The lobes of the brain and their overlying bones of the skull have the same names. So the frontal lobes and the frontal bones of the skull. Now, right at the back here, this is the bit that you see with at the back. So at the back of the brain here, there's a smaller lobe at the back where we have vision. And this is the occipital lobe. So the occipital lobe at the back where we see. The light comes in through the eyes at the front, of course, but the image is actually generated by the brain in the occipital lobe, right at the back, where, of course, it's dark. So all the light you're seeing now, you're actually seeing in darkness because it's being generated by your brain, giving you this consciousness of vision, the occipital lobe. Now, this large lobe up here is the parietal lobe. So the parietal lobe is here, and then the lobe just above your ears, this lobe just here, is the temporal lobe. The temporal lobe. And the brainstem is actually divided into three sections as well. The top part of the brain stem here is the midbrain. The middle part here is the pons. And this lower part, the lowest part of the brain stem, is the medulla oblongata. The medulla oblongata. So they're the main parts of the brain, just looking at one side of the brain. Because the cerebrum and the cerebellum are in two hemispheres. But let's carry on looking at this side view and think about a few more components of the brain. Now there's an area here in the frontal lobe, and that's called the frontal eye fields. The frontal eye fields. And that's good because it lets you look very precisely at things. And we can put our eyes exactly where we want to. So right now you can tell I'm looking at you directly into your eyes. Controlled by the frontal eye fields. Now also in the frontal lobe, but at the back of the frontal lobe, here, this area, so this is frontal lobe in front of the red line. This would be called the central sulcus, this area, the central sulcus. A sulcus is where the brain dips down into a little valley. So anything in front of the central sulcus is frontal lobe. So this is the back of the frontal lobe, and this is the motor cortex. The motor cortex. And the motor cortex is where all movement is initiated. So we have a motor cortex, and the body is represented more or less upside down. So the mouth and things might be there, the body, the hands probably kind of in the middle, and the feet towards the top. That's called the motor little man, or of course if you're female, the motor little woman. And it's called a homunculus. So if you look at pictures of the homunculi, you can see the areas of cortical representation, moving parts of the body. And of course it's the left motor cortex that's going to be controlling the right side of the body. And it's the right motor cortex that's going to be controlling the left side of the body. So whenever you want to move something, the motor neurons, the motor neuronal cell bodies in that area are very obliging, and just because you will it to happen, they generate a brand new nerve impulse just so you can move whatever part of the body you'd like to move. This is kind of the interaction between mind and body, really. The mind decides it would like to move something, and the appropriate motor neurons in the motor cortex generate the brand new nerve impulse specifically for us to move the appropriate part of the body. Now, just here is an interesting area of the brain, and traditionally this has been called Broca's area. Broca's area. And this is what turns thoughts into speech. It turns thoughts into speech. It forms the words ready for us to say. It doesn't articulate your mouth and your lips so you can say the words. That's going to be the motor cortex. But it gives you the word. So, what do you call... Oh, that's right, it's a pen, isn't it? That's a pen. So when you want to name something, this takes the idea from your mind and gives you the name. And sometimes you might be thinking, oh, what's he called? Or what do you call one of those? That's when you're waiting for this Broca's area to give you the right word to express the concept that you would like to communicate. And at the back, there's another area about here. And this area is traditionally called Vernix area. And this is where we understand speech. So if you're understanding the words I'm saying to you now, the words are being translated into the concepts that those words represent by this Vernix area of the brain. And if you're right-handed, it's almost for sure that these speech centres will be in the left-hand side of your brain. Now, most parts of the brain are represented on both sides, but the speech areas are just in one of the cerebral hemispheres. Now, there's another useful area here. This is the front of the parietal lobe. And in the front of the parietal lobe, we have another homunculus, another little man or another little woman. So they're kind of going to be here. They're of similar shape to the motor one, but they've got bigger hands and bigger lips, so they're not quite the same. And this is the sensory cortex. So this was the motor, this is the sensory. The sensory cortex. And this is where everything that you feel is experienced. It's where you experience your tactility. So you're going to feel your lips round about there. You're going to feel your hands round about there. You're going to feel your feet round about there. It is where the body image is generated. And again, all this right side of the body here, you are feeling with your left sensory cortex in your parietal lobe. Or the left side of the body, you're feeling that in your right sensory cortex at the front of your right parietal lobe. So that is the sensory areas of the brain. And just below that in the temporal lobe here, there's another useful area here. And these are the auditory areas. This is where you are hearing, the sense of hearing. So when you hear things, you're hearing them. The sound is going to be generated by the temporal lobe. So if you're listening to words, you're going to hear the sound with your temporal lobe. That's what makes you aware of the auditory stimulus. But the meaning is going to be given to those words by the Vernix area in the speech recognition centre. In order to reply, to have a conversation, the concepts are turned into words by the Broca's area in the frontal lobe, and the information goes to the speech apparatus located or controlled by the motor cortex. Now, the cerebellum controls automatic learned function. So this is the cerebellum here. Now, when you're a child, or if you watch a child writing, they go, and they think about each letter. But now you can just do it automatically, because your cerebellum controls automatic learned function. Or when you're tying your shoelaces, you can do it without thinking about it. Or when you're driving a car or riding a bike, you can do it without thinking about it, because the cerebellum is controlling automatic learned function. And it's also adjusting all the muscles of the body to give us posture and give us quite a bit of balance in the cerebellum. So lots of automatic functions going on to free us up to think about things, to interact with the world using the cerebrum. We won't do details of the brainstem, but let's notice the medulla oblongata. It's got some amazing centres in it. So, for example, the medulla oblongata has got a cardiac centre, which is controlling the heart. It's got a respiratory centre, which is controlling respiration. And it's got a vasomotor centre, which is controlling the vascular tone and therefore the blood pressure in the body. And in many countries in the world now, we define death as death of the brainstem. And if you see someone with brainstem death, if they're not ventilated, when you turn the ventilator off, they will just stop breathing straight away because the respiratory centre in the brainstem would be dead under that situation. The heart will keep beating because of the internal electrical conducting system. So the medulla oblongata is controlling a lot of the autonomic functions. So there we have the main areas of the brain and a little bit about what they do.